But maybe with a little practice, I could tell myself to relax it. Will be better next time I try. And even if I still can't do it, yeah, you know that I'm gonna stick to it. Yes, it's all about going through it, and I'm gonna tell you why. Whoopsie, whoopsies, I made a mistake and it's okay. It's okay. Whoopsies are what it takes to get better and better every day. Whoopsies, I made a mistake and it's okay. It's okay. Whoopsies, help me look, see, I'm better at this today. Woo! Whoopsie, 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 whoopsies.
I'm a little embarrassed when I look at my drawing compared to this. I'm just not getting anywhere with this. It makes me wanna hide. Aw, don't be embarrassed. Don't hide.
You should have seen mine the first time I tried. It took a lot of whoopsies to look this way.
No one's perfect on their first day. Whoopsie.
Whoopsies, I made a mistake and it's okay.
It's okay. Whoopsies are what it takes to get better and better every day. Whoopsie, 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 whoopsies.
Well, what about this? I want to jump rope, but nope, I just can't do it.
Well, not yet. Come on and practice with me. You'll see there's nothing to it.
Whoa! Whoopsie.
Whoopsies, I made a mistake and it's okay. It's okay. Whoopsies, help me look, see, I'm better at this today. Woo!
Wait.
It was only a dream, the waves of evil crashing over us. It was only a weak and faithful scream beneath the battlements. I know it's hard to follow before it's too dark. Wake up, my love, please don't give up on me. It's hard. Wake up. It was only a dream, the waves of evil crashing over us. It was only a weak and faithful scream beneath the battlements. But I know it's hard to follow before it's too dark. Wake up, my love, please don't give up on me.
What is up? What is up, you guys? We are back again, doing another amazing day of 100 days of Rootkit. Are y'all hyped or what? What is it? Day 17. Here we go. What an adventure we have stored in place today. I'm gonna let you know it's gonna be kind of rough at the beginning. Let me switch over to the better, chiller music. Can I play? There we go. It's gonna be kind of rough at the beginning because looking through some of the stuff in the networking is a little outdated. It's not on the exams, so if you did try to learn it, it would have just been pros for you. But the big thing we're getting into, TCP/IP today. I am hyped. It's going to be a lot of awesome information that's super relevant that you can go and mess with today. It's going to be sweet. But before we move any further, if I can get my tab here. We're Rootkit. We're a non-profit. We're streaming for 100 days, teaching you all the things you need to know in order to get our comp sci cert, which is a complete replacement for a college degree. All right. Also, you know, we are a charity, so everything that you donate to us, at least in the US, is going to be 100% tax deductible. So save on them taxes. If you come over here to our Streamlabs charity, we have, sorry, I thought I heard something. All right, you can donate to us directly and start helping filling up that bar up at top. All right, we also got some awesome merch. I mean, look at this sweater. Look how beautiful this sweater is. Look at the back. It even says Rootkit. It's so warm. It's so snuggly. You want one. I know you want one. I want one. I have one right now. It's awesome. Look, if you don't have any money, it's all right. Because if you go to our site, right here, we're doing our week 3 giveaway. And we're giving away one of these for free. All right? All you have to do is enter, subscribe to the YouTube channel, and other basic tasks like subscribe to Twitch. All right? And you'll be entered in to win. All right, we sent a bunch of rewards already. A lot of people have already claimed theirs. I think there's one that hasn't gone unclaimed yet. So if it hits the end of the week, we'll be re-rolling on that one. But we've sent off a lot of merch so far, and we're going to send off more. Specifically, these exclusive stickers. I know you want one, all right? These exclusive stickers are awesome, all right? We have 3 of them. And the only way you're ever going to be able to get them is here on the stream via the giveaways or by donating right here. All right, look at this. I mean, this one right here, that's one of the stickers. See, look how cool that one is. Oh, it's right here on this side. So get one of them stickers. All right, now if you're following along, if you go to GitHub and go to our org, you'll see our comp sci cert roadmap. And here we are completing networks and protocols right now, and we are over in section 3. And I think we might even be able to get through some of section 4. We'll see moving forward if how everything is going and how everyone feels. All right. Did I hit everything? I think I just about did. Let me turn down this music just a tad. There we go. Sweet. For those of you who are new and joining, thank you for joining. For those who are coming back once again for another epic day, welcome back. You guys are the real Bamfs, all right? I need that hoodie. Yep, I feel it. It's day 17. Let's go and hype. I feel it. I feel it. I feel it. Let's continue our epic quest through this sea of, oh my god, $100 from Apple! I hope that dance was very underwhelming for you. That was the kind of the point I was going for. So rudely interrupted me, alright? No, thanks so much for the donation. That is super awesome, super awesome. AFO is super awesome, and Again, if I didn't mention it, all donations up for the first 10,000 are being matched 1-for-1. The anonymous donor will be matching them at the end of every single month, up to 10,000. All right. So every time you donate, it's like you're donating twice as much. So that's really a $200 donation. It's even more epic than 100. All right. Make sure you claim yourself some delicious merch. All right. Let me get some more water here. I want that panda. Oh yeah. I don't know. I don't think I showed off this one. And then here's the last one. Look at that. Look at how adorable that is. It looks super non-saturated on the camera, but it's alright. Also, this is probably the rarest of the stickers we have. Right here. Rootkit to the Moon. We've only sent this to a small handful of people. Very exclusive to get this sticker. It's for people that really go above and beyond, particularly our champions that go above and beyond, or if you win specific events that we give on our Discord. So either that's through the daily rewards that you can claim, or through stuff like our hackathons that we do. And we call them Hack the Flags, because they're kind of like capture the flags, but involve software development, a good amount of software development. Oh yeah, the hoodie is $150, buddy. You get in line, all right. All right. Let's dive into it, I guess. Does anyone have any questions before we move on? Oh, also, we are doing low latency on YouTube this time, so you guys are like 5 seconds delayed. All right, so it's very fast for people on YouTube now, even faster than the people on Twitch. All right, because I don't really care for Twitch, but YouTube, that's where it's at. All right, it's all about the Google overlords. All right, let's move on here. Let's talk about some cables. Finishing up with some cables and some transferring. Again, some of these items here we will either skip or just barely touch because they are not on the exam. These are items that we have been removing because when we talked to companies we're partnered with, it's on average not really seen as valuable, and you'll get a better coverage of it if you take a certification exam like CompTIA's Net Plus. So if you want to learn more about this stuff, definitely take CompTIA's Net Plus. All right. Now, transoceanic cables. Let me paint this picture. You wake up, go to your computer or your phone in the morning, and you just load up your favorite movie. All right. Then, after the sorry, let me roll back here. You load up your favorite anime, all right, and then you go on YouTube afterwards, and they recommend you some review videos of new anime because you're very into anime, and they have an advertiser that's trying to sell you on some weeboo stuff, all right, that you're really into because you're a little weeb, all right. You click on the link, and it sends you to a Japanese site that will that you can purchase, I don't know, Japanese Kit Kat bars or something, and they will ship them to you. A lot of people take that for granted, that whole process there, because what a lot of people don't know, and it's really a modern marvel, is how did you connect to servers in Japan if you're in the US or if you're in Europe, all right? How did you do it? Well, there has to be physical cables. Sure, satellites are becoming more and more common, and satellites are a way you can traverse great distances, but there has to be cables. Satellites are very, very slow. Cables are fast. There has to be cables connecting you. So there's these things called transoceanic cables, and there are a lot of them right now, and they span tens of thousands of miles across every single ocean. and they are quite impressive and they are quite massive, and I highly recommend you checking out some of the YouTube videos that are out there on individuals laying these cables. All right, it is quite epic. And what is going on with the YouTube stream here? Hold on. There we go. It is quite epic. So these are literally massive cables that lay on the ocean floor and traverse entire continents through, I don't know, we'll just click on, I want to find a really densely packed one. Literally every ocean, all right? Atlantic, Pacific, Indian, the Arctic, all right? They are all over the place. They are laid from usually popular hubs, so like New York to London and other various other coastal cities, and then throughout South America and Africa, they'll be at densely populated cities that can be hubs to then send it over landlines, all right? But these, again, tens of thousands of miles of these massive cables are laid, and they're continuously being laid. Why? Because new things like better fiber comes out, faster transmission rates, and you gotta lay new cable. There's no way you can really upgrade a lot of the existing cable besides laying new, better hardware. So they have to find the money and do it. And there is a lot of money in this. This is where the power of your ISPs come from, and basically this goes into what you are paying for when you're paying for your internet provider. You are paying for the maintenance fees and the ability to traverse over these networks, because again, there's a very limited amount of cables that can go from, let's say you're in the US, you have to go, typically when you're connecting to somewhere like Japan, you will go, no matter where you are in the US, you will go to the West Coast and your connection will hop to Japan over these cables. Most typically, you can force it to go another direction, but most typically it will go through the West Coast and over to Japan. That is very limited in your bandwidth because there's only, it looks like a lot of cables and there are a good amount, but there's a limited amount. So if a lot of people are wanting to do international connections, these lines can get clogged. And this is why a lot of your data, when you try to go to foreign countries' sites and so forth, you're typically slowed down because of the bandwidth. Not really because of the ping and how long it takes to actually talk to these servers. That is a slow connection and a slow back and forth, but usually it's the limiting factor is how much data can fit through these pipes, because you're not the only one sending data across these lines. And a big thing is a lot of big cloud providers and big companies, they have databases and other data storage software that they would like to be synced across potentially multiple continents, all right? And to do that, they need to transfer a large amount of data from servers all around the world to other servers around the world, which means they're usually the main spammer in these lines. So who's laying down these lines? That's a great question. Well, cloud providers are very incentivized to lay down these lines to have their own dedicated ones, since they are using them all the time. So you will see that there are multiple lines laid down by companies like Google, and I believe there are lines that are laid down by Facebook and Microsoft. And let's go ahead and see if we can get some articles here. Let's see if the wiki page talks about. So you can see here, this is a big breakdown. So before moving forward, big takeaway, these are cables that go across the ocean, all right? That's all you need to know. Everything we're talking about now is a little bit of extra stuff. All cables, asterisks, I don't want to make an all claim, but pretty much all cables now that are being laid are going to be fiber, all right? Because fiber can go further and it's cheaper to keep that connection alive because it's just light compared to electricity having to be pumped through these cables. All right. So they are very protected. As you can see, there's plastic, there's tape, there's steel wires, there's aluminum barriers, more plastic, copper, oil, and then your actual fibers, all to protect it, because there's a lot of things that can go wrong. There's storms, there's boats that can run into these things, there's sharks that can run into these things. A lot of things can go incredibly wrong, and it's very expensive to go out and reach and fix these cables. We have any questions so far? So the first cables that were laid were very, very long time ago, and they were for the telegraph system. And then after that, the telephone system, because people wanted to communicate across the whole world. And so the only way to do that, again, is by laying these cables. So you can see here, there's some history about the telegraph system and things being laid across these oceans to make these connections for telegraph, then telephone. And the early internet used telephone. So the early internet was building off of the telephone communication lines that were being laid to provide the internet. And later on, actual heavy duty lines were laid down to provide just straight up big boy bandwidth for the internet. All right. A lot of stuff here. I'm trying to look for who's been laying. Here we go. So Google, this is not the only time they've laid down stuff. I know they've laid down a bunch of other times, but Google has laid down a lot of cables for their stuff. Facebook and Google laid down cables here. And let's see where else. Microsoft, I know, has laid down cables. You guys can look into this a little bit more if you're interested in, but there's big money in it. All right. I think AT&T was one of the biggest ones early on to lay down these cables for the US, because they used to be the biggest provider and one of the biggest companies in the US, period. But that is no longer the case anymore. And I know there's sites also, yeah, I think this is it right here, that have live maps of all the cables that have been laid, and you can click on them and you can see exactly where they go and who owns them. So this is owned by multiple people, because again, it's very expensive, so usually people will go into it together. So it looks like it's mostly Chinese companies, and then some I believe this is South Korean, SoftBank, and then Microsoft. All right, and you can literally just look for days on this. All right, and look at all these cables. Now, just know this is where things kind of get sometimes sketchy, because in the US, whether you want to believe so or not, I don't really care. I'm going to tell you anyways, you have protections, all right? Believe it or not, you do. And same thing with you if you're in EU countries or the United Kingdom. And then if you're elsewhere, depends on how corrupt your government is. I'm sorry. That's just how things go, I guess, over there. It's pretty hardcore. You're living on the edge. But no one can just la-di-da look at your data that's being transmitted over these lines. But if you're using submarine cables to go to a different country, they don't need to respect you. You're not a citizen there. So be aware, if you're doing illegal activity over in different countries, you can be monitored freely by whoever wants to monitor you, all right? You're not being protected by your own country's laws. All right, any questions on that before we chug on forward? So we're going to talk about these three next, just very lightly. They're not really on the test, but we're going to just talk about them real quick. So effectively, there's ratings on these cables and just cables in general that get laid down. And I mean the big boy cables that are the backbone of the internet and the telephone network, all right? They have ratings, and these are the like type of rating systems. I tried looking for graphs earlier, but effectively these are the speeds and the capabilities that these cables are capable of doing. And T, I believe, should be referencing, and it says T carrier there, but I believe it should be also referencing the trunk cable. Couldn't really find what I was looking for. E carrier is older stuff, all right, for telephone lines. Then digital signal came next, and then after that we got fiber, baby. So now we use OC, and OC stands for optical carry transmission rates, which are the new fast rates on the market for these types of lines. Additionally, mixed in there, we have a technology called SONET, which is built on top of these fiber lines to offer even higher bandwidth across these lines. All right. So basically, slow, faster, even faster, and then fastest. Those will not be on the test. All right. So don't really worry too much about those ones. But let's talk about DSL. This is important because when you have these, I wish I didn't close that tab. 1 second. I'm about to sneeze. Maybe not. Never mind. Forget it. All right, we're moving on. DSL. All right. DSL. Let me pull up my my notes here. Where are they at? Not this one. This one. Oh no. Give me my notes. There we go. So, in general, DSL is kind of a bigger boy. It's a I mean, you can see these other ones are part of DSL. I'm trying to think of the word. It's like the parent of a bunch of other stuff. So it's a modulation scheme specifically for copper wiring. So any big copper cables, that's what DSL is for, right? And it's for packing data onto copper lines, the lines that are meant for like internet data or telephone lines, all right? And they allow for pretty high speeds, but they are limited. These lines, these copper lines, are laid down, and this is used across transatlantic and submarine cables and over land lines, right? Most commonly, we talked about Xfinity a lot or Comcast a lot yesterday, and we're going to talk about them more. They use a lot of copper cables, and so they use this, all right? Specifically, there are 3 modes you can send data across it, because again, these copper cables are very limited in their capacity of data they can send across. So there is some potential sacrifices you have to make. So let's take a look at some of these sacrifices. There's asymmetric DSL, symmetric DSL, and very high bitrate DSL, right? So asymmetric DSL. Asymmetric means that things are not the same, all right? This is pretty common for most people, at least here in North America, to have an asymmetric DSL connection through their internet provider. What does this mean? You've probably been mad at this a lot. It means that these companies will advertise to you 100 megabit internet, all right? Asterisk, download speed only. And then your upload speed will be way worse. Typically, it is 10% of what your download speed is. That's asymmetric DSL. Usually, it doesn't have to be because the download speed is higher, but one is higher than the other. It's asymmetric. Allows for faster transmission of either download or upload speeds. Now, why would the ISPs do this? Are they just trying to screw you over? Well, if you read all the conspiracy theories and whatever else crap is on the internet, yeah, sure, They're trying to screw you over. In reality, because you're here at Rootkit and you're now smart and educated, they're doing it because you have a pipe that's limited. Think of it like water going through a pipe. There's only so much water you can send through the pipe. So if most people on average are heavy users of downloading traffic, so visiting like sites and then downloading that information, downloading pictures, streaming movies, those are all down operations. Those are all operations going down to you. Then if I'm limited, I'm going to prioritize down speeds, right? I'm going to give you as much down speeds as possible without hopefully compromising your up speeds, because the average user does not need very much up speeds, all right? So that's why they usually do the 10%, your up speeds will be 10% of what your down speeds are. Any questions on that? Also, if I didn't mention earlier on, I am in the events chat in Discord, so you guys are free to join in and ask questions as you see fit, right? Now, if you do a speed test, you'll easily be able to figure out if you have asymmetric DSL, because you'll see that your down speeds are high and your upload speed should be 10% of what your down is. If you see that they're the same, then you have symmetric DSL, right? That means that your up and down speeds are the same. When it comes to copper, aka DSL land, this is typically what you find when you're paying for business class internet. You'll find that you'll usually be able to get DSL or symmetric DSL or request it from your ISP. Also, if you do fiber, even though this is for copper land, fiber land has such high bandwidths, usually you will get symmetric speeds. So usually if you have fiber, it will be both the same for upload and download speeds, which is another plus in the fiber bucket. All right, and then there is very high bitrate DSL, which is for speeds that are very, very fast, usually at 100 megabits per second. It can be potentially even higher for that, all right? And it's just a way of, I'm not gonna even say that. It's just for very, very high transmission rates, all right? Any questions on that? All right, we're gonna move on here, and we're gonna get into satellite territory, because I don't see any questions right now. So let's talk about satellites a little bit, shall we? Satellites are cool, right? They're a bunch of space computers just flying around, chilling out. So satellites, you can think back, they can have potentially two major styles of orbits, all right? Now, there's a lot of math and calculations you can go into figuring out how to get a satellite into one of these orbits compared to the other one, but we're just going to talk about them. All right, there's geostationary orbits, which means that as the Earth goes around the sun and rotates, the satellite will always be at the exact same side of the Earth. It will never change its position or what it's able to see. Let me see if I can get a picture for this. Let's go ahead and use this picture. So this guy right here is hovering over this area of Earth. As the Earth spins, it will match it one for one. It will always be located over this part of land. It will never not be located over this part of land. It's perfectly stationary. It's geostationary orbit or geosynchronous orbit, however you want to call it. it means they are in sync or it's in stationary from a geological point of view. If you look up, it's literally always going to be in the same spot. It will always be above you at all times. Now there's another type of orbit which is non-geostationary orbit, all right? Also known as elliptical orbit. So this means that the satellite's just going to keep on going around the Earth at whatever speed it's going to go. It's never going to be above you constantly. It's always going to be like zooming past you, and maybe it'll be like a while before you even see it again because it's like on a weird angle, so it's just doing a bunch of crazy stuff. This is where most of Starlink satellites are located at. They are located very, very, very low because geostationary orbits require you to be very, very far away from the Earth, while elliptical orbits or non-stationary orbits, you can be pretty much anywhere else you want. You can be further away, you can be closer to the Earth. Starlink satellites are very, very, very close to the Earth, and they're moving at whatever rate they want to move at. Now, when you have satellites, you're going to have this thing called a footprint, right? And what the footprint is, where's that picture? I saw one that's a good example. We can use that one, but I saw, where is... Oh, this one right here. Right here, this is what the satellite's able to see. That is its footprint. It's exactly what a zone it's able to cover on Earth. So Starlink satellites have a lot of them in space because they are very close to the Earth and they don't have that big of a footprint. So you need a lot of them in order to cover everything. But again, why they're so close is it comes down to that speed. Like I talked about before and I hit on multiple times, is your biggest limiting factor, and there's no way you can improve this, period. It is fundamental to the laws of physics that this is a limitation and will forever be, is that things can only go as fast as the speed of light. So when you are transmitting data from satellites across fiber, across copper lines, distance is your enemy. The further things are away, the more latency you will have. So typically, before really Starlink started deploying their satellites, most satellites that provided internet were in geosynchronous orbits, very, very, very far away from the Earth. Typically, if you want to reach out to one of these satellites, it will take about 500 milliseconds round trip time. So you to reach out and it to come back would take about 500 milliseconds just to do some basic communication. A half a second. That's very, very slow, very, very laggy. Compared to now the Starlink satellites, who are all in low Earth orbits, so very, very low, and they are not geosynchronous. They are very, very fast. I have a Starlink. I've used it before. It's pretty much as fast as your normal internet provider. It's quite impressive. So they're able to do that because they are way, 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 way closer to the Earth. But the only downfall again is that footprint. So footprint is what a satellite is able to see. Any questions on that? All right, and then in order to talk to a satellite, you need some way to interface with it. So VSATs are the typical method for interacting with satellites. I'm not 100% positive if the Starlink's terminals are able to or are classified as VSATs. I would imagine they are. I think they are. Oh, never mind, I read this wrong. In most cases, yeah, so they are VSATs because they are small devices that allow for two-way communication, all right? Very small devices, two-way communication. So I got one right here in the box. Oh, all right. I'm not going to show that side. But as you can see, it's very, very small. I can talk to satellites now. It is way below the 1.2 meter range, or I guess 3.8 meter range for size. And it allows for two-way communications. As you can see, in most cases, your connection is really, really slow. Starlink has completely changed that, and now you can get over 300 down megabits per second down speeds, which is absolutely insane compared to what people were dealing with before. It was funny because I took a flight the other day, and I was on a boat the other day, and I've taken lots of flights before, and a lot of them have satellite internet. It's usually pretty much worthless. You know, you can't really do anything on it, but it was using Starlink, and it was fast. It was really, really good. It was pretty much like you were using just normal internet at home. Same thing with the boat I was on. It was using just Starlink, and the internet was just absolutely insane. You're in the middle of nowhere ocean, and you're getting speeds that a lot of people get at home. It's pretty impressive. It is really impressive. Any questions so far? So that pretty much covers that section. Now we're moving on to TCP and OSI. Sorry, I said that wrong. This is a lot of information we're going to hit on, and this is going to be some pretty cool high-speed stuff. This is very important stuff. This stuff will be tested on. This is a lot of stuff. It's very important. You will use this all the time as a developer. There's no way to get around it. If you want to be a developer, you have to know these things. You as a normal consumer every day, you are using these things and you just don't even know it. You can look at your web address here and you can see that you're using protocols, all right? And they're a part of these protocol suites. You play games, trust me, your lag, the protocol suites are very important to that. All right, so we're going to talk about those next. But before we do, I think it's going to be good to go on a break, mentally prepare ourselves for the journey we're about to go on. All right? Any questions before we go on break? And if we do go on break and you do have questions, go ahead and just throw them in the chat and I will answer them when we get back. All right? All right, I'll see you guys in a couple of minutes. What is up? What is up? We are back at it again. Oh boy, are you guys ready? Because this is going to be some fun stuff. We're going to start in the conceptual realm, and then we're going to work down and see the practical implications of all this. If you've downloaded Wireshark, this will be a fun opportunity for you to mess with Wireshark. If you haven't downloaded Wireshark, go ahead and type in Wireshark, and it will be the first link, and then you can go and download it. It is a free application. I'm going to go ahead and put this in both of the chats here. Highly recommend downloading it for this part. I'm also going to put it in the Discord once again. For those of you guys that have access to the Discord. So go ahead and download that, and while you're doing that, let's talk about concepts a little bit. You guys have seen a lot about hardware. You learned about cables more than you really wanted to ever know about cables, all right? And we learned a little bit about certain hardwares, and we're going to get into more hardware here in a second. Particularly, you've learned about network interface cards, NICs. That's what you can plug cables into. Yeah, we'll definitely get into these ones pretty quickly after this. But how does everything conceptually work with each other? And people conceptually don't agree. There's two big parties on how to think about it conceptually. And that will be one, the TCP model. All right, and that's one that we're going to be talking about. And let me pull this up. This will be perfect. And then there's the OSI model, all right, which is more classical. TCP is, people are slightly favoring it right now, but OSI is the classical one. So, God, these are, here we go. Let's just start here with TCP, and let's actually Google our OSI model. So, first, let's talk about OSI stands for Open Systems Interconnections, and TCP/IP is going to stand for IP is, so IP, this is the same IP as like IP addresses and stuff that you've heard about or you've probably used. This is going to be your internet protocol, all right? And then TCP is going to be your, if it doesn't come up, your transmission control protocol. That's what it's, oh, here it is. Transmission control protocol, all right? So let's go to these images. So we talked about cables, right? Cables are actually sending data in the form of electricity, all right? It's the raw fundamental level of all of this. It's literally like the equivalent of you going up to your light switch and just toggling it on and off. You are transmitting data over the light sources, all right? That's what this data link layer at the bottom is equivalent to, all right? Anything that's at this level is the raw data, and you're dealing with connections between hardware, all right? Hardware to hardware connections, and the only way these connections can really talk to each other or know about each other is based off hardware identifiers or hardware IDs. And we'll get more into that here in a second. Particularly, it would be your MAC addresses, which may be a term that you've heard of before. That's the only way things at this layer can communicate with each other, is at this hardware fundamental layer. Now, on top of that, you can build on top of that. Kind of think of this as, what is a great example? Would a house be a good example? Maybe a house will be a good example. I'm just going to go with the house model. So this is going to be basically like all your wood for the house. It's not too much, but do I want to go with the... let me think of something else. We'll move forward for now, and I'll think of something better. If someone has a better analogy and they want to throw it in the chat, just go ahead and throw it in the chat, and I'll roll with that. So on top of that, you can transfer data on the data link layer, but you can do networking on the layer above it, and effectively your data will be wrapped. So data link will wrap around networking, and networking will be inside of it. It's basically like some inception stuff, and inside that will be your transport stuff, and inside that will be your application stuff. Think of it like an onion, and the more useful information that you use on a day-to-day basis will be towards the center. And in order to transport this onion, you have to literally look and peel away the layers to figure out where you need to go and how you need to go about functioning. Another way you can think about this is kind of like your computer. Your computer has hardware, which would be kind of like the data link layer. And your hardware can communicate with each other, and at a certain point, things start going into software mode, aka maybe like the networking side of things you can think of. Then after that, you can start getting into the operating system, and the operating system sits on top of that hardware, and then on top of that operating system, you can now download applications like Google Chrome or your games, and that would be like the application layer. You're kind of building up. You start with something basic, and you're building up and adding more layers on top of that. That's kind of what's going here with the TCP model. The OSI model is the exact same thing, except there's more layers, and this kind of breaks it out nicely. There's more layers. They're basically taking these four and they're saying, we want more. We want to split this up even more. And that's why I initially clicked on this one, because this is kind of how they're linked together. So on OSI, you'll see that there is physical and data link. All right, these are combined in the data link layer for TCP/IP. So the physical layer will be again like that, just the electricity is the bits, it's the on and off, that's it. Data link will be the making sense of that electricity and allowing hardware to communicate to each other. The networking section will be now allowing different networks, allowing them to communicate with each other and not dependent on the underlying hardware to a certain extent. On top of that is going to be your transport, which is going to be how you want to go about communicating. Do I just want to shout at you 24/7 and just tell you things, and maybe you'll hear them, maybe you're not? Or do I want to have like a more civil conversation and like say something, wait for you to say something back, and then I'll respond? How you want to transport that data to other computers is dealt with here. Session layer is going to be dealing with actual active sessions, so how long things are potentially lasting for. Presentation layer is going to be getting into, it says here for your encryption, your compression, and text stuff. And then application layer is going to be what you're utilizing for usable applications you use on your computer, like for example HTTP. So we're using web right now. Web sits here at the application layer. So everything you do in your browser is done here at this layer. I'm trying my hardest right now to, oh, this is the classic image right here. This will make more sense as we move forward. It's kind of like basic math when we first talked about it. Basic math was like a little rough at first, but then when we started getting into more concepts, everything started clicking and making more sense. So we're starting right here. I also like this picture, which we'll get into more and more often as we move forward. Again, why TCP is also kind of favored, it simplifies because the application presentation and session layer sometimes can be all of the same, aka all inside of the same application. So you'll see that a lot with some of these protocols here. TCP and UDP are going to be your transport layer stuff. IP routing will be here at your network or your internet layer. And then Ethernet, token ring communications, the ATM and the frame layer are all going to happen here. We're going to get into all of these guys. All right. The main thing that you need to know in the exam is you need to know both these models, their layers, and what can be running on potentially on these layers. So if I ask you where TCP is going to be running on the OSI model, you need to answer with transport. If I ask for the TCP IP model, you only need to answer with transport. If I ask for Telnet, where's that running, you're going to have to answer for the TCP IP model application layer, and then for the OSI model, I believe that will also be application layer. So we're going to go through a bunch of these guys here. Are there any questions on this so far? All right, so let's move on forward here. And let me see my book. Let's talk about these layers a little bit more. So we're about to get into APIs. And APIs are something that you'll hear used a lot. They stand for Application Programming Interfaces. And effectively, what these are is they're interfaces to allow you to interact with something. So let's say you buy a drill at the hardware store. There's a button on the drill that allows you to interact with that drill and get some type of useful functionality out of it. That's what APIs essentially do. They're a bunch of buttons that you can potentially press, and when you press those buttons, you'll get some type of response or functionality out of them. And these buttons exist for everything that you use. Chrome has these buttons, Windows has these programming buttons, languages have these programming buttons that you're able to do, and they all live here at the application layer. And you as a developer, especially when we get into the programming part, you will be working with and creating from scratch your own APIs, your own application programming interfaces. All right. So remember, these are going to live at layer 7. Pressing all these buttons to get functionality, layer 7. APIs are going to be at layer 7. Okay. So let's talk about this thing called the protocol data unit. Yes, protocol data unit. You know, before moving forward, I think we're gonna take a step back and we're going to load up Wireshark, all right? I think this will make more sense when we look at Wireshark, because this again is all in the networking realm. So stuff that we're sending across the internet. Now I gotta click on yes like a million times. Gosh, all right, come on. Why? There we go. All right. Hopefully, you guys I didn't lose you guys from the streaming stuff from that. Okay. So if we load up Wireshark and we click on our Ethernet adapter, or if you have wireless, click on your wireless adapter, you're gonna get a lot of stuff that gets sent across. There we go. That's being sent across your cabling. I'm gonna go and stop that. And you're gonna see there's a lot of stuff here. There's a lot of stuff going on. There's a lot of data that's being transferred. Now, this data is following those OSI and TCP IP models, and we can kind of look at them and see the breakdown of them real time. So let's actually look at, do I want to look at this one? Can I, the stream is just clogging up all this stuff, but let me see if I can load, oh here, let me start this again and let me load a web page. So let's go to rootkit.com. There we go, and we'll stop that. Can I just find rootkit.com from looking at this? Probably not. Let's see, TCP and 443. I don't think that's too much. Is there any 80 here? Oh, there it is. All right, we're gonna look at this one. All right, I don't know what this is for, but we're gonna look at it. So if we look at this right here should look kind of familiar. So this is a packet of data. So keyword right there, a packet of data that was sent across your cabling to your computer to transfer you some type of data. This is HTTP data, so when you're going to a website, this is what will be pulled up. So we went to some type of website, and now this is the data that we got. Now let's pull up side by side here our model here. Let's go with OSI first. Physical layer is the actual cabling and the electricity we're sending in order to send those messages. So we won't see that here on the computer per se, but that's what is at that level, all right? And this is typically broken up into these things called frames at this level. So that's just the way you can chunk up data, because let's say you wanted to download a 100 gigabyte file. You can't just have a perfectly non-stop streaming of all of that data at once. It doesn't really work, because it's just a lot of data. 100 gigs, that's just too much at any point, and you might clog up the network and not allow anyone else to communicate. You don't want to do that, right? So what they do is they break it up into frames. So this happens automatically, and your data is basically cut up, chunked up into little slices, and sent as individual packets across the internet. All right, that allows for other people to intertwine their traffic on these cables at the same time, so no one's being clogged up or not allowed on the network. So after that, so you'll see the frame is the entire data. This used to be binary data. It still is binary data. What Wireshark does right here on this side, and this chunk side, so in this, you'll see there's a big left side. I guess it kind of looks like there's three chunks, but this first chunk right over here below my mouse and this chunk, this is all a part of the same thing. And then this is another interpretation. It should look kind of familiar, because this chunk over here below my mouse is hex. All right, it's in hex, because displaying all the binary would be annoying to look at, and this is much way more understandable for the average person to look at and understand what's going on. And then beside that, over here is the translation into ASCII or potentially Unicode. All right, so that's why you'll see actual text, because that you'll see the highlighted sections there. That's the hex version of the text, and this is the actual text. And things that it's not able to translate properly will show up as those little dots. So this is at the so if I highlight over here, because you're going to see a bunch of layers here, which are very similar. They are the same layers that you're going to be getting over here to a certain extent. So here is our Ethernet layer, which is going to be at the data link section. All right, data link section is what allows computers to talk to each other. All right, and computers deal with hardware, so they have hardware addresses. So if we look here specifically, if I open this up a little bit, I don't really like how this is formatted, but we'll see that there are actually two addresses in here. There's a destination address and a source address. All right, these are your MAC addresses. That's what they are called, and we'll get into that more here in a little bit. But this is what hardware, when they're very close to each other, aka not across the internet. All right, the internet uses IP to talk to each other, internet protocol. But when you're typically in your own LAN, your devices will now use the MAC addresses to communicate with each other. So we have our MAC addresses here, which will basically allow for data to be sent from my router to my computer. So these will be my router MAC address, and then my computer's MAC address. If this is coming, yeah, this is source to my computer. All right. So this is going to be your data link. On top of that, you'll see literally nested inside of it, right below. See that highlighted area? It's Ethernet, and then right below that is your IP or your internet protocol. And there's specifically version 4 and version 6. We'll get that more later. But this is wrapped, like I said, like an onion. It's a layer that's underneath Ethernet. Now this allows for you to communicate across the internet, aka network with other devices in long distances. Devices that maybe are within your LAN, but usually when things are outside of your LAN, aka across your router, like servers that you want to communicate, websites you want to go to, games that you want to play and connect to, they'll be wrapped in this guy, your IP layer over here in the network layer. This is purely for routing on where you want to go, what server you want to connect to. But once you connect to that server, you need to establish how you want to communicate to them. Because there are multiple ways and methods you can go about communicating with servers. You can do things like TCP, which is Transmission Control Protocol, which we'll get more details here in a little bit once we get past these models. But it's effectively you saying, "Hi, how are you doing?" And the other computer says, "Oh, I'm doing good." And they have a little handshake, and then they chat back and forth really nicely, like they're some high-class people. All right, and then when they're done, they have a little handshake at the end, and they walk away from each other. It's very civil, all right? But you don't have to talk like that. You could talk like super crazy and just be like yelling at someone and be like, "Ah, ah, 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 ah." And maybe they'll yell back at you, maybe not, but it's pretty much a one-sided conversation. That would be UDP, all right? The diagram control protocol. I don't know. We'll look it up here in a second. I never remember what the U stands for. But that's going to be your transport layer, right? Because that's you communicating how you want to talk to these computers. So as a recap, physical, ones and zeros at the wire level. They have no conscience or sentient knowledge of anything. They are just ones and zeros. Data link is when things start becoming smart, all right? That's for hardware interacting with other hardware in the same network, aka usually within a LAN, your router communicating to your computer, or if you want to communicate from your computer within the same LAN to another computer because you're hosting your own server, or whatever else you're doing. All right. Then on top of that is your network layer. We're in IPv4 territory or your AP territory. This is when you want to potentially go further outside of your LAN, out to the normal internet, and connect with a server. Doesn't matter what that server is, game server, web server, file server, doesn't matter. You want to connect to another computer outside. All right. So this will get you there. This will connect you. But once you're connected, you need to then figure out how you want to communicate to each other, right? And how you solve and tell the other server how you guys want to communicate with each other is going to be your transport layer, all right? This TCP thing here, all right? That's the civil way of talking. UDP is the non-civil way of talking. It is just straight up yelling, all right? So now that we're able to transport, we figured out how we want to talk to each other, and now we're able to transport data. We've now entered into pretty much 5, 6, and 7 layers. The session, presentation, and application layers, which is basically the data, the actual data itself you want to transport. This depends. These layers sometimes don't even exist. Session and presentation don't exist when we're just doing HTTP. It's just application. So now you can kind of see why OSI isn't really favored sometimes, because they're not applicable. Actually, a large amount of time they aren't like literally applicable. They're just kind of existing there. All right. So this may not be no bueno. Now, where presentation would be applicable, if some of you guys saw over here, HTTPS and SSL and TLS, these are encrypted traffic. These are ways to encrypt your traffic when you're sending it. And again, this is all done pretty much at the application layer. So aka some programmer said they want to encode data when transporting it like this. It's kind of like, let's see here. It's kind of like the transport is like a semi-truck, right? This TCP is like a semi-truck, all right, where it's just sending data along, and inside its cargo bay, there's stuff. What type of stuff? Who cares? The transport person doesn't really care, all right? But you, when you're taking delivery of your cargo, you care. And these layers are pretty much like, do you just want your, let's say you're shipping food. Do you just want your produce, specifically produce, do you just want your produce just thrown back there, like bananas and stuff, or just thrown in the back there and taken to your warehouse and dumped? That's pretty much you skipping session and presentation and only doing application. It's just the end result thing that you have is there and you dump it. Presentation might, you know, put it into nice boxes, all right, make it like nice and orderly so they don't get bruised and stuff like that. They'll usually secure the produce. Keyword being secure the produce, all right? That's where this encryption stuff usually comes into play. It's usually what's securing the data or your produce at application layer 7. So right now we are accessing the web in an unsecure fashion, which means anyone that's listening to my traffic can see any data I'm sending to this website. Now, if we were to encrypt it, we're then using the presentation layer, and this will no longer be understandable to the normal person. So if we look over at something like, let's see here, TCP port 443. If we look at something like this, here we go. This one's perfect. I think this is during a handshake. All right, we're gonna move forward with this one. I don't know if it's an appropriate packet, but the point gets across. This looks like a bunch of garbage, right? This bunch of garbage is what you see when things are encrypted. All right, you can't understand it. It's 100% secure. No one can understand what I'm doing when I send my passwords, when I'm looking at my bank information, etc., etc. It's 100% now encrypted and secure. My presentation layer is helping me do a secure presentation. All right, and then the session layer is pretty much a way to keep things connected or end things gracefully in connections. It's basically a connection on a connection, because we talked about here before, your network layer will go out and make an initial connection with something. Then it's on the transport layer to negotiate how you'll be sending data back and forth. The session layer is kind of a mimic of these guys, but in your own custom way. We'll maybe get to an example of that. These ones we won't really talk about too much, but let's go and look again at TCP/IP. Or this simplifies it a lot. You have the data link layer, which is the raw cabling and computers talking to each other via their hardware IDs. Then we have networking, so reaching out to a server, all right, doing that initial connection. Then transport is basically how are we going to talk to each other, and then application is just an application, a custom program that you make yourself as a developer, and how you want to go about doing things with that data. All right, it's a nice simplification, and this is usually like the use case for everything. OSI is just very, very specific. Any questions on that? That was like a lot. Hi, Potato Studios. I see you said hi. I like that name, Potato Studios. A lot of stuff. Again, for the exam, for OSI, you will need to know, I guess, the actual name, International Organization of Standards. It's kind of like IEEE, but it's a different version. All right, this is OSI, and they have the model. The model is 7 layers. You need to know each one of those layers, and you should know at least one protocol or like use case for each one of those layers. So these pictures are great because they tell you right beside it what is being used at each one of these layers. Right? The protocol data unit is it's another labeling for this stuff on what type of data is being sent. So again, let me open this picture. If you have any questions, please ask them in the chat. This is a lot of stuff we're covering, and I'm not quite sure how good of a job I'm doing right now for you guys. But again, the physical layer is going to be, this is your wiring. It's going to be sending, again, just raw electricity, ones and zeros, because it's turning on and off. At the data link layer, you're going to be getting frames, right? So the whole thing here is going to be your frame, right? It's going to be just cut up. It's going to take your data at large, and it's going to cut it up into small little bits and send it across the way towards you, all right? Your packets are going to be, can't speak for others, but looks good so far. Awesome, awesome. So your packets are also going to be cut up. Well, let me check my notes here for because I'm forgetting right now the distinguishing factors between the frame and the packet. All right, let's do our Googling. If you don't know, then you Google, because we're your devs, and devs need to be good at Googling. You should always Google whenever you don't know anything. It's not a crime not to know. You should always Google. Most of your work, again, we've said this a million times, and I'm going to say it a million times more. Most of your potential as to being a great dev is how good you are at figuring things out. Googling, researching, finding the answer. Finding the answer might be 80% Googling, The other 20% might be trial and error, trying things, making things break, you potentially breaking things with your hands because you're angry. All right, if you are not constantly getting angry and wanting to break your computer because it's not like the programs you're trying to make aren't working, you're not being a good dev. All right, you're not pushing yourself to the edge, and you should always be doing that as a dev. So let's go ahead and look in here and let's type in frames versus packets. So while a packet is a unit of data used by the network layer, a frame is a unit of data used in OSI's data link. A frame contains more information about the transmitted message than a packet. This was not very useful. All right. Packets are carried inside of frames. Yeah, I could have told you that one. Okay. Well, this is the labeling for it. Don't get too hung up on it. We do test for the labeling. Again, if you take Net Plus by CompTIA, because this is starting to enter into the IT CompTIA Net Plus IT realm, Net Plus is going to be your cert if you like this stuff or you're interested in this stuff. This is the one you want to get, and there are a lot of jobs you can get with this cert. All right, so if you want to learn more about this stuff in depth, then get your Net Plus cert. Right now for the exam, I'll tell you, we will just test you on the names. So just know the names and how they coordinate. So bits go with physical layer, frames go at data link, packets go at network, segments go at transport, and everything else is going to be data. Right? So you'll have to memorize those ones. Let's see here. APIs. Again, APIs, application. They're at the top layer. They're ways for you to press buttons in programs and mess with stuff. You will be making a lot of these. Right? As a programmer, this is your bread and butter. Right? And you guys will get plenty of practice of this. So don't worry too much. You don't need to read into it too much. We will be using this term a lot when we get to programming, and you will be very familiar with this guy. Any questions so far? If there are no questions so far, I would prefer to also just get these ones out of the way, and then we can call that a day. So if that sounds good to you guys, we can go ahead and do that. Again, mostly I want to say, like, I know it kind of sucks for the OSI TCP/IP models. A lot of them are, especially at this stage, is kind of just brute memorizing. And trust me, it is applicable. It is something that you want to know because it is something that you will utilize all the time, usually almost to an unconscious state when you're interacting with systems. But it is something that is important that will come into play a lot as you being a great dev, right? Trust us on this one. And I will constantly refer, as we move forward, I will be referring back to these models and pointing out how everything is connected to them. So we keep reinforcing that stuff. So if you aren't too clear with them right now, don't worry. We're going to keep reinforcing and hammering the different layers and how they're connected to pieces of hardware and when you're programming, etc., etc. Hopefully the Wireshark example kind of helped with you, because now you're actually seeing actual live real stuff, and how the connections are kind of being made here. And hopefully now you can kind of see why we went over hex, all right? And we talked about Unicode and ASCII, because this section over here, I'm not sure if it's Unicode, but I know for a fact it's going to be trying to interpret stuff as ASCII. All right. So we're going to go on a break, and when we come back, don't see any rebuttals for it. When we come back, we're going to go over and talk about a couple of these networking devices. They are very important, and we will be showing you how they fit into the OSI and TCP model, and then we will call that good for today before we get into the beautiful world of addressing. All right, if you guys have questions while we're on break, go ahead and just plug them into the chat. I'll see you guys in a couple of minutes. What is up? What is up? We are back. Hopefully that was a long enough break for you guys to mentally... What was that? I already forgot what it was. That break wasn't long enough for me, I guess. It's, mentally recover, alright? From the loads of data that we just talked about. Again, 100 days of rootkit. We are going pretty fast right now, I'm gonna be honest, and typical people that are going through our stuff, Usually takes them, if they're really on top of everything, 6 months, but up to a year for a lot of people to really ingest and nail this information. So you guys are really taking in a lot of stuff right now, so it is very, very impressive. All right, and also if you have questions, that's okay. I want you to have questions, because again, it's a lot of information. All right, but this again is going to be everything and more than what they will teach you at college. All right, that is what makes our certification so powerful. These are the things that people want you to know when you're getting a job. A lot of boot camps are straight up scams because they don't teach you these things. They teach you the basics of how to program and say, go, get out of here. Oh, also first give me your $20,000. Now get out of here. All right. They're straight up scams. All right. Don't get fooled. Don't waste your money on them. They are not going to help you land those jobs that you want, because the jobs that you want, they want you to know this base information. You have to have a good foundation of these foundational, good knowledge of these foundational items in order to become a good programmer, because everything you do programming wise directly is interfacing with these. You are sending data across cables at all times. You are using an operating system. You need to know about the hardware you're utilizing, all right? These are all important things to know. All right. So, I see there are no questions so far. You glitched, lol. Hopefully the glitching has stopped. Alright, so let's move forward. NICs should be very familiar. Also, you'll see there are lots of acronyms. No matter where you go, whether you want to be a dental assistant, to a plumber, to a programmer, to someone that flies planes, to whatever, you name the job. There are going to be lots of acronyms in every job, because these words, who wants to say International Organization for Standardization? Like that, too much, all right? We're all lazy. Specifically, programmers are lazy, all right? So we're going to use lots and lots of acronyms. A lot of this is not just learning the original term, but also learning the acronym version of it. I mean, you can see right below this point, we're using the acronym point. All right, NICs. I'm going to be referring them as NICs. All right, NICs are important. You usually have NICs in your computer by default when you buy from the store. Again, your NIC is going to be how your computer interfaces with these cabling, with the cabling devices, in order to allow you to participate on a network. Okay, let's go ahead and pull up our book here, because it's going to help out a little bit, specifically with bringing the layers together. So again, your NIC is going to be the interface for your computer and the network, particularly like a network medium, so your cabling. All right, usually there will be drivers, which is a software. Drivers specifically are software that are specific. They're labeled with driver because they are interfacing with hardware and software. They are helping with the conversion and understanding of the ones and zero at the raw hardware level, and what you're able to actually use when you want to program or use it in an operating system or in your program or application, right? So typically these drivers will be managed and maintained by the operating system. So Windows, for example, whenever you plug in a new mouse or a USB drive, you'll usually see something that pops up saying it's automatically downloading the drivers for you. They're not the only things that need drivers. Your graphics cards, if you've built your own computer, or if you bought a brand new graphics card, you've had to download drivers in order to get things to work correctly. Everything has drivers to an extent to help it work correctly. So NICs are going to be working at layer 2 of the OSI model, all right, and the network layer of the TCP/IP model, all right? So this is you taking in data from the wires. This is not the wire itself. These wires itself are the ones and zeros, all right? That's the medium. The medium is going to be layer 1, all right? NICs work at layer 2 because that's the hardware device that you're sending information from to something else, or you're receiving information. So if we look here again, a hardware layer is going to be our Ethernet, where we have these hardware IDs, aka known as MAC addresses. Okay, these MAC addresses are literally usually unique identifiers that were made by the manufacturer and literally soldered onto the board. So they're hardwired to the board as that ID, and there's no real way to change it. Asterisk. There's ways to change it now. Even Windows allows you to do MAC address emulation or swapping or so forth. So there's ways you can change them out, but by default they are made by the manufacturer and they're put in there. You'll see even names like ASUS and Arcanian, whatever this is. These are manufacturer names because the MAC addresses, how they're made is they're allotted to companies. Certain ranges of them are allotted to companies. So when you're using something like Wireshark, they'll look at this and they'll look at their known range of addresses that are assigned to companies, and they'll be able to tell you, usually with pretty good accuracy, who made that hardware that you're utilizing. All right. So, any questions on this? We got just some extra information here, like the link lights. So those are going to be the lights that you see. If they're blinking, it means that you have connections and things are going across. All right. Pull up the chats here. No questions. We're going to move on to the next guy. Let's talk about repeaters. Repeaters are super important. We got repeaters here as our second item, because a lot of the cabling that we've looked at, even fiber lines that we looked at that are great, they can only send a signal so far. I mean, if you ever taken like a flashlight when it's really dark outside and you point it into a given direction, you can light up a good amount of area really close to you, but if it's something really far away, it pretty much just remains dark and you can't see it still, because things will, you'll have a loss of signal over a distance called attenuation, right? Everything does this when it's in the electromagnetic spectrum, aka lights, radio waves, electricity signals. As they keep going further, since they have to pass through mediums, because we're not in a vacuum, all right? We're not in space. So if we were in space, you're in a vacuum, so they can keep moving forward further without disruptions. But they still have a spread. I won't even get into that. But when you have fiber or electric cables, you have to pass through the medium. So there will be attenuation where the signal keeps getting weaker and weaker and weaker. Most fiber cables can only go, I think it said like 1,000 meters before the signal's pretty much like dead. So in order to help keep things alive and allow you to do things like have cables that go across the entire ocean, you will need things called repeaters, which are basically amplifiers. So if you ever played musical instruments or anything like that, like a guitar, you might be used to and accustomed to amps that will amplify the sound of your guitar. That's exactly what repeaters do. They will take a signal and they will amplify it and make it louder so it can go travel further. So you can see here, here's an example of a repeater on a transatlantic cable, because you need a lot of these, and this also adds to the cost and expense of them in order to keep that signal alive and going across. All right, and this is dealing again with that raw data, that ones and zeros, the signals. It's dealing with that low level stuff. So these will be working at layer 1 of the OSI model and the network layer of the TCP IP suite. Because we're dealing with just raw signals, electricity, all right, light. Any questions on that? Sweet. Let's talk about Hubs, the next guy on here. So if you're connecting things around your house, and I don't know, say you live in a mansion or something, and you notice that you're at like 100 feet of Ethernet cable. Ethernet cable usually isn't rated to go as far as a lot of high-end fiber cable. So you should look up the rating, but if you notice you're getting bad performance, it might be because your cable is too long and you might be losing the quality of your signal, and you might, need a repeater to help you. So keep that in mind. Repeaters can help you in those situations. Now we have hubs. Hubs are great, useful, but also very dumb devices. They're pretty much like, think of them as hubs as like a news network hub or something like that. You as an individual, when you say something, maybe you don't have that much of a reach and people can't really hear it very well. So you can go through maybe a news network or something who has a large reach. They're a hub of information that people will go to ingest some type of data. A hub kind of works the same way, where you as one person can send signals to a hub, and the hub will broadcast it loudly to every device connected to it. All right, so you can see here you can have up to 4 Ethernet connections on this hub. This hub will broadcast anything that you send to it across all these devices. Now, this can be great or a security issue for you, because you're sending data to everything. All right, if this is sensitive data that you don't want everyone to have, you don't want to be broadcasting it to everyone. All right, that could be a potential issue for you. So hubs may not be what you want. So just know that is a limitation of hubs. Now, things are in place for your computers, so by default, they won't listen or pick up on that traffic. Even if it's sent to them, it will just ignore it. But you can still set up things like Wireshark to potentially listen to that ignored traffic if you're on a hub. All right, and hubs again are going to be transmitting and relaying data. It's just a relay. It's just like a repeater. It's just getting data and transmitting it everywhere. It's not very smart. It's a very dumb device. So it works at layer 1 and the network layer of the TCP/IP suite, right? Also, you need to be aware that hubs are broadcasting just everywhere, so you can potentially run into collision issues with other devices and computers. Either both of them are someone is trying to say something at the same time you're broadcasting something, and you'll run into collisions like that, or potentially other collisions in regards to people having maybe the same MAC address or same IP address, or there can be a lot of things that go wrong. So hubs, dumb devices, can be useful, usually not, but you shouldn't be aware of them because maybe it will be useful for you, something that you are making. Any questions on hubs? I got a hardware example for the next one. I think the next one is what I'm thinking of. Let me see if I can grab it. Here we go. Oh, there we go. I'm breaking stuff. I'm dying. All right, sweet. Is the next one what I think it is? Yes, it is. All right. Next one is switches. Switches look really, really similar to hubs. All right. Switches look, again, very, very similar to hubs, but there are some very distinct differences between them. Here's a switch that I have here. So switches are extremely useful, and you will see them be commonly used at pretty much every business location out there. All right. Why? Because go look at your router, for example. Your router, for example, typically routers, let me see, like a normal, I'm just talking about normal consumer routers. Home router. So your normal consumer router, I mean, even at the corporate level, this can be a potential issue. So your normal consumer router will have very limited available ports at the back. So we got a blue one back there, which is going to be for the incoming internet from your modem, all right? And then you got these 4 guys here, which is for computers you want to connect. If you have a lot of computers that are in your home, you may use up all 4 of them. So what do? You use a switch. Or maybe that you have a computer but it's really far away, and beside that computer you have like another 1 or 2 computers. All right, maybe it's your brother's, your sister's, your wife's computer that's right beside you, and you don't want to run multiple cables from the router all the way to the room that's on the other side of the house and have like multiple cables everywhere. It'd be easier if there was just one cable that you could potentially split off and make multiple cables of. That's what a switch is for. Switches are the smart version of a hub. All right, hub will broadcast everything everywhere. A switch is smart. Switches are conscious of who lives on every single port. All right, they know who is where. They are conscious of the addresses, the MAC addresses for the devices that are connected. So we have our MAC address here on my computer, and you can see this will be the source one. So this one is mine right here. All right, the ASUS MAC address. All right, so this guy will see what my MAC address is, and it will memorize that. And when you try to send data across this device, it will switch what direction the data needs to go in order to only send it ever to exactly who is supposed to receive it. So if you're sending data on a switch, the only person that will receive that data is the person it's meant to go for. It's not going to broadcast it broadly to everyone. It's only going to send it to who needs it. So this can be, again, very useful. I have one here by my computer where basically I have one port is plugged into the router, another one's into my computer, another one's into another computer, and I can keep connecting computers and expand my available ports. As you can see, this one has 8 that I can utilize. All right, you'll see these at businesses a lot because businesses have lots of computers potentially, or security cameras, or whatever they have. So you might need to expand the amount of ports that you have. So that's what switches are great for. Now, the key word I said there was in regards to the models, the OSI model and stuff, is that this guy will look at the MAC addresses in order to intelligently send data where it needs to be sent. If you're looking at the MAC addresses, that means you're not just dumbly retransmitting raw data. You're looking at the second layer, all right, of the OSI model. Or in the TCP model, you're looking at the network layer also, because they're all kind of in the same wrapped up situation. Now, be aware, there are ways you can, quote unquote, exploit switches, all right? One of them is doing an ARP attack. Forgetting the exact term of it. Everyone knows, you can put it in the chat. But basically, there's this thing in here called a MAT. M-A-T. A MAC address translate. It is a MAT on here, right? Pretty sure it's a MAT. But it's a table. Again, it needs to know where all this data is supposed to go for it to do the switching. So there's a table in here that stores that information. Now, you could fill up that table. All these devices have limited amount of memory. So if you fill up that table, this guy may get really confused and might not know what to do. So a lot of them, by default, if that table ever fills up, they'll auto transform into a hub. So these guys are capable of turning into a hub if ever needed. All right. But no, that's an exploit that's something that can be exploited, because if you are a bad actor on a network, all right, you may want to flood and confuse a switch in order to get it to become a hub and send you all the data of everyone that is connected to this, so you can snoop on someone else. All right, and we'll go over more in detail here, I think tomorrow. Is it in here, or is it later on? I think it might be later on, but we're going to go into detail more on how you can go about performing that hack and that exploit. And there are literally just tools laying around on the web that will allow you to perform the exploit. And it's a feature for these to do that, not a bug. It's intentionally done on a lot of them. Some of them you can get without that type of integration in it, but it is something they are capable of. All right, any questions on that? If not, let's move on to routers. And now I feel like powerful. I got something in my hands. All right, I can just mess around with it, wave it around. Routers. Again, you guys are used to the home router usually, which is again a combo device. Typically, it's going to be a router and a WAP. All right. No, get your mind out of the gutter. Not that type of WAP. We ain't talking about music here. We're talking about a wireless access point. All right. God, you guys are terrible. All right. So they're usually a combo of a router and a WAP. But in business world, if you were to work at AWS or something, they're going to have just hardware routers only, no WAP installed in them. So right here you can see a picture of a router without the WAP in it at all, and this is just a big beastie router for handling a lot of traffic. And you'll see these in server situations. And again, this is for routing traffic, right? That's what their name isn't lying to you. It's for routing traffic, either for local usage or for internet usage, that wide area network, that WAN usage, right? They're the gateway, aka this is a really good keyword for you to memorize. They're the gateway, they're the gatekeeper. They protect your local area network. It is very hard. It is, again, very hard. It is very hard. I'm going to say it again. It is very, very, very hard for someone to crack through your router and get into your local area network. The things you see in the movies are generally lies. No one is going to be like, oh, I got your IP address. Now I'm going to break through your router and get onto your local area network. No, that's not usually how hacks happen. Routers are usually have pretty good software on them, and it's very difficult to get past them. There are easier ways to get into a network beside that. We won't get into that right now. But routers are the gatekeeper. They hold the floodgates back. All the bad things that are out there on the internet, they stop a lot of it from potentially getting into your network because they're the gatekeeper. You can only enter this network that it's gatekeeping if you are allowed to. So the only ways you could be allowed to enter the network is if someone inside the network, aka you at your computer, reaches out to a server and says, hey, give me some data. The router will see that you initiated that convo and will allow for that data to get back into your closed off network. It is the gatekeeper. It is the gate master, all right? It is the guardian guarding your vault or whatever you want to have the guardian do, all right? If someone tries to initiate a conversation with your computer from the outside world, they will hit that router, and that router will be like, get the hell out of here. What the hell are you doing? Like, no one asked for you. Get out. Go, get out of here. That is the router's job, all right? So, gatekeeper, gateway, remember that word. It's for routing traffic. It is what makes different LANs. So every router, anything connected to a router, will be potentially within its same within a new LAN, and you can have multiple LANs together with multiple network or routers on top, and they can be combined together in order to allow for cross communications. And these hardware items build the whole internet. This is literally all the internet's built off of, is routers, servers, repeaters, switches, and hubs. That's pretty much, I guess, firewalls, but that's for mostly security. That's it. That is the whole internet. There's no hidden anything else. That is it. So to pull up an example here, and by example I mean we're gonna be looking at my beautiful drawings that I'm definitely saving and going to be publishing as NFTs for you guys to purchase, and then me to pull the rug on them. All right, we're all about rug pulls here, right, you guys? So let's show how you can now form the internet with your knowledge. Before we move on, let's actually talk about what layer these guys work on. Routers work on layer 3 because they're dealing in routing internet traffic, IP addresses, all right? They're not dealing with hardware stuff. Hardware stuff is done from computer to computer within the same network, or when you're using these switches. You can send from one computer, can send something to another port to another computer directly. All right, it's looking at the hardware stuff. Routers, you're entering an internet world. All right, so you're going to be using IP addresses to talk to each other. So you're going to be dealing layer 3 on the OSI model and the internet layer of the TCP/IP suite. All right, let's look up here. So you have your cool router. Let's say you want to go off the grid. All right, you're super cool. All right, you're going off the grid. You live in the middle of nowhere, but you don't want to be too lonely. All right, you have a buddy who lives next door who's also off the grid. You guys are both living in the middle of nowhere, Alaska. All right, it's just you guys, and you guys are both geeks though, so you guys both have servers that you run, and maybe your buddy has like a movie server that has a bunch of movies on it, so you want to be able to watch those movies. All right, you will have a router, and this router will make your little custom personal protected local area network, your little LAN. All right, I'm gonna put a box around your router here. So your router is going to be on. I want to actually do the router here and then like half like this, like half exposed, because it is half exposed. It's the gatekeeper between the cruel world and your safe haven. All right, so we got our LAN. Our LAN is everything inside of the router. This router can be connected to anything inside the LAN. Let's say it's hooked up to a switch, all right, and that switch has a bunch of ports, all right? And this goes to maybe your personal computer, one goes to your phone, and another one goes to your cool server. Maybe you're hosting a game server, all right? Anyone within your LAN can talk to anyone else within your LAN without much difficulty, all right? There's nothing holding back anything. If I wanted to, if you wanted to, you could spam your phone and try to just spam it with internet traffic, or just made up traffic basically, and make it incapable of talking on the within the LAN itself. If you wanted, you can do anything you want in your little world, in your little bubble here. But you have your cool neighbor. Your cool neighbor over here. Let's do a different color for the neighbor. Let's do this color. Your cool neighbor over here also has a router, because that's what's needed in order to have your LAN, all right? And they have, all right, my mouse is glitching out a little bit. LAN, this is their LAN, and they have, let's say, a switch that's connected to their router that allows them to connect a bunch of a bunch more devices, and they have, let's say, a bunch of servers. So let's say server 1, let's say this is server 2. This one is their movie server. This one is their phone, and this one's their computer. All right. You guys are completely isolated. You're in the middle of nowhere, Alaska. You're completely isolated, but you guys want to hang out and chill and play some games. Well, you guys are using routers. Routers are the key thing to the internet. They allow different bubbles of LANs to be connected to each other. All right. So what you guys are capable of doing, if you want to be able to hang out, play games on your game server, and watch movies on his movie server, you guys could take a cable and plug it into one router and then plug it into the other router, and now you guys have a connection. This is a mini little internet. That was really bad. Internet. All right, it's a little mini internet. This would be more classified as a LAN, wide area network, because you have multiple networks in a wide area connecting to each other. But this is the basis of the internet. This is literally how the internet works. You are paying ISPs to set up cables and a lot of routers to connect you to these little bubbles that exist everywhere. That's all the internet is. The internet can go down in certain areas if these cables ever get damaged or taken down. That's why during a storm, your power may go down along with your internet, because they're usually hung right next to each other. So when those cables go out, those cables are out. So any questions on this at all? There's a key thing I talked about earlier about there's gatekeepers. They deny anything that wasn't initially formed. The request wasn't initially formed within their LAN. All right. There are ways to get around this. All right. There's this thing called port forwarding, which we'll get into more later, but it's effectively you telling, hey, Mr. Gatekeeper Router Man, when they tried to talk to me about, let's say over here, when they try to talk about games, let that connection through. All right, that's okay. They can come in and play games, all right? But when they do talk about games, the only person they're allowed to talk about internally would be our little game server right here. So the router will only allow connections now into the network about games specifically to this guy and this guy only. So you can allow for wild internet traffic to come into your network in a safe fashion. You can dictate exactly where it's allowed to go, period, and it's not allowed to do anything else. So that's what we're going to do there. And then your buddy over here is going to say, hey, when they want to watch movies, I want you to not block that. I want you just to send them to my movie server over here. All right. So now we have, it's all now in a state more like the internet. Our computer and our phone can talk to each other locally here, but there's no way in the world that my computer can talk directly to this computer over here in this LAN. It's impossible. You cannot do it. It's impossible because the gatekeeper, the gateway, the router is blocking that. It will not allow anything through at all except what is allowed or initially started from a computer in here, so aka my client right here, and to an allowed resource, aka like movie. So if my computer wants to go across here and say, hey, Mr. Router Man, I want to go watch some movies, he'll say, okay, I see you're allowed to do that, so it's going to go connect me to the movie server, and that's going to be a connection out. Now the movie server, once I've selected my movie, will want to send that movie to me. So now this data is going back this way. But since we started the connection internally, the router is going to see this incoming one, and it's going to be like, ah, you're good, buddy. Come on in. I see that one of our VIP guests said you're legit enough, so you can enter in. And so then you will be able to talk directly to the computer. So again, that's kind of how routers work. And we'll slowly get into this more and more as we move forward. Any questions on that? And everything in here is dealing with IP addresses. So your devices will have 2 addresses typically. They will have a MAC address and an IP address. All right. Every one of your devices here are going to have a MAC address and an IP address. MAC addresses are for this inner circle. All right. IP addresses are going to be for routing outside to anything in the internet land. Difference between layer 2 and layer 3, all right? Any questions on that? Do we even, yeah, I'm not gonna even go over this. Any questions at all? Because this is pretty much the conclusion of our chat today. So we went over a lot of things. We went over 3, 4, and 5 today. All right, a lot of stuff, a lot of important stuff here in the models. Hopefully this is now making more sense. We've done a lot of examples. We showed off Wireshark. We talked about the hardware. We talked about how the hardware works on layers 1 through 3 for the OSI, and 1 and 2, so networking and internet for the transportation. Data link networking for the transportation. For the TCP/IP suite. Any questions at all? I'm gonna chill out here for like another second too. If you guys have any questions, if not, we'll be continuing tomorrow, 7 p.m. on our epic journey, and we're going to get into addressing. This is going to be pretty much us living in IP land, dealing with mainly IP addresses, mainly things at layer 3 of the OSI model, and the networking layer of the TCP/IP model. All right, there's a lot of ways you can make connections, all right, and how you talk about those connections and go about those connections, all right, and they're super, super important, all right. If you want to be a back-end dev, front-end dev, working on operating systems, satellite systems, you need to know this stuff. Just about everything you're going to do. You want to do machine learning? Guess what? You're going to have to do machine learning most likely on clusters. How are you going to network those clusters together? You're going to need to know this information. You want to get into the IT world? You need to know this information, especially if you're going to get into the IT world, all right? Because you're laying all this stuff down and making it from scratch a lot of the times. Not like programming it from scratch, but you're connecting hardware and thinking about how to make all those connections from scratch. If you want to be a DevOps engineer, you need to know this stuff. If you're working in AWS, in Google Cloud, in Azure, in Alibaba, whatever, you need to know this stuff, or else you won't be able to appropriately go about hooking up your connections. This is important at every step of your programming career. All right, you want to be a hacker, an exploit analyst, you need to know this stuff. All right, exploits need to get there somehow. They need to travel across the network. They need to communicate back to someone. They need to be listening for a connection later on. This all deals with networking. All right, networking. It's one of the most important things we're going to go over in the fundamentals. You need to know this stuff. All right. Particularly this address stuff, to an extent, tomorrow is going to be very, very important. I mean, all of this stuff is pretty darn important. And we're going to finish this whole thing off with hacks. So network security, it's the nicer way of saying hacks, hacking, exploits, bad things, malware. Right? We're going to talk about all these guys. We're going to give examples. We're going to show off how you can do some yourself, how you can download some. Right? We're going to show you how you can become a hacker. But you can only do that if you know these things. These things are important. I don't really see any questions, so this is your guys' last chance to ask any questions before we end today's stream and we continue our epic journey through the questing of conquering these bullet point items. I don't know, I'm trying to be cool and fancy, right? If there are no other questions, I think we're going to call this good. We'll continue again, like I said, 7 p.m. tomorrow. I will see you guys on the next one.